I am Swabhiman Swai, a student of Section 20, bearing roll number 20MT30026, and I worked under the portfolio of circuit designing and video editing for this project, and I also helped with the coding part.
Hello everyone, myself Devraj Shrutikari. My roll number is 20NU10015. I have mainly done the coding part of this project. Except from that, I have also run the simulations and checked and reviewed the whole project. Except that, I have also distributed works among my team members and helped in other works. Thank you.
Hello guys, this is Satvik. My roll number is 20NA134.
Hello guys, this is Manoj of section 20, roll number 20 NA30009. For my DIY project, we have done the UVC based germs disinfecting mission. On behalf of my project, I have done the FreeCAD model. And to learn about it, let's get into the video. Hello guys, now I am going to tell about the basic features and the characteristics of the mission we have created. The main idea of this UVC germs disinfecting mission is to sanitize any product using the UVC light only, and it kills the germs by 360 degrees. It works on the commands given by the user. It is a mobile COVID sanitization mission, that is, it cannot be operated by the user manually. The unique features of this mission are: it is a portable mission, it is a completely 360 degree sanitization mission, it is a non-touch sanitization mission. You cannot fear about while touching the mission it will cause any damage. It is only it uses only UVC lights to kill the germs completely. It cannot use any other sources to kill germs. And then we know that the UV disinfecting chambers have already came into the market, but the main feature they have left to implement on that missions are 360-degree all surface disinfection. But in our project we have facilitated the 360-degree all surface disinfection by the flipping the items automatically using servo motors. The project we have created is a very useful thing in this current scenario of the pandemic. Since the virus is spreading by the surface contamination, we need to clean all the things we have used, such as a phone, purse, keys, and then mask, face mask, etc. We need to sanitize those all very cleanly. So we have created this mission to sanitize it without no touch, so there is no chance of contamination from our mission side. So since it is very cheap and portable, we can transport to the home, we can move it to the shop, and then we can move it to the office. Wherever you want, you can use it. It is a very useful mission. If you are interested, you can also go through this. Main activity of this UVC lamp is it releases the UVC rays, which can kill the germs present on the object we have placed in these two trays. After completing one side disinfect, the servo motor will flip these trays by 180 degrees, and then other side also disinfected. Okay guys, thank you for listening. Hello guys, this is Manoj of section 20. Now I'm going to explain my FreeCAD model of the mission. Here you can see these are the outer surfaces of my mission, and then you can see also this one, and then this one. These two both are the servo motors which are connected to these two trays. Use it to flip these trays by clockwise direction 180 degrees. And then you can also see the these are the two threads I have used which are connected to the stepper motor, which is placed at the back side. The mechanism of the stepper motor is if we need to place the objects on these two trays, two metal trays, then this tray will open by the stepper motor due to by mechanism we applied, and then it will also close the due to the stepper motor also it will close after placing the objects. And also you can see the here is the UVC lamp.
Now let's try and understand this circuit design a bit better. We have used two servo motors which operate in the range of 4.8 to 6 volts, producing an output torque of 1.6 kg centimeter at 4.8 volts. And the operating speed for these servo motors is 0.12 second per 60 degree. We have also used an ultrasonic distance sensor, which you can see here, which operates under 5 volt DC power and has a detection distance of 2 centimeter to 400 centimeter. We have also used two IR sensor modules. One of them is for driving the tray in and out, and the other is for switching on and off the UV lamp, which we have used in our project. It has a detection distance of 2 to 10 centimeter and detection angle of 35 degrees. That is, it can't measure anything beyond these 35 degrees. These operate under a DC voltage of 3 to 5 volts. We also have used a stepper motor which is bipolar in nature and has a step angle of 1.8 degrees per step, holding torque of 2.4 kg centimeter and current per phase of 1.5 ampere. The rated voltage of this stepper motor is 12 to 24 volts, and in our circuit it operates at 15.4 volts. We also have used the stepper motor driver which operates in the range of 8 to 35 volts, having a minimum logic voltage of 3 volts and a maximum logic voltage of 5.5 volts. We also have used a 1 ampere SPDT 1 channel 5 volt relay which has a maximum current of 20 milliamps, and at 250 volt of AC power it allows 10 ampere current, and at 5 volt DC power it allows the same amount of current, that is 10 amperes. We have also used a LCD display which would make the entire project interactive as well as attractive. We have also used an Arduino MKR Wi-Fi 1010 which allows to connect with Wi-Fi.
Hello everyone. Now I will describe the coding part of this project. Basically, we have used two microcontrollers for our work. Our primary microcontroller is Arduino MKR Wi-Fi 1010 and our secondary microcontroller is Arduino Uno. We have used the Arduino Uno for controlling our servo motors, which are basically doing the work of flipping the plates on which the objects are being placed. In this code, I will explain how the Arduino Uno is controlling the servo motors. First, we have included the servo.h library, which is the basic standard library pre-installed in the Arduino IDE for controlling the servo motors. Then we have created two objects of the type servo, that is servo 1 and servo 2, and we have assigned them two positions of initial 0 positions. Now in this part we are using some variables for taking inputs from the Arduino MKR Wi-Fi 1010 board. These are variables for timers, time 1, time 2, and an integer timer initially assigned to 1000. And in this setup part, we are basically setting up the servo connections by using the function attach. Now in this loop, we will continuously check for the input from Arduino MKR Wi-Fi. As soon as the sliding plate comes in, then the servo motor will start the process of changing their positions. So here we have used another function called digital read, which will take the input from Arduino MKR Wi-Fi and assign its value to the variable itself called as value. So if value equal to 0, time 1 will be millis, and if value equal to 1, then again we will assign the value to the digital read of input, that we will assign its value to the 0 initially, and we will assign the time 2 variable to this value. Now if time 2 minus time 1 greater than timer, then we will initiate the function flip. By this function flip, we will change the position of the plates by use of the servo motors. So basically what is it doing, time 2 is the time spent till now, and time 1 is the time to which the objects are being sanitized. If this time is greater than a particular time, after that we will desanitize the other surface of the object, so we'll flip it. Now let's see how the flip function works. So in the flip function, we have used again two functions called servo control 1, delay 1000, servo control 2, and again after that delay 1000. So basically what are we doing? First we are flipping the our first plate, that is the first servo motor, then we are delaying a bit time, and after that we are again doing the flipping of the second plate. So now let's see how this servo control function works. As you can see, servo control taking 1 and 2 like integers. So this is the int x. If x equal to 1, then we will change the position, angular position of the first servo plate or the first servo motor. For this we are using the servo dot write functions. Then again we are delaying some time, and then again we are changing the position. Basically we are doing a flip of total 180-degree. So between that we are delaying a bit for the efficient use of the servo motors. And if this integer is 2, that means we are getting instructions from the Arduino board to flip the position of the second servo motor. And also for this we are doing a total 180-degree flip, and between them we are also delaying a bit time for the efficient use of the servo motors. Else if we are getting nothing, that we are getting x as nothing 1 and 2, that means we don't have to change the position of any of the servo motors, and so we are retaining its position as it is, means we are not flipping themselves. So here I have basically explained the first flipping procedure of the two servo motors. But in our machine actually the servo motors only flip the object, not the plate. Means after doing a flipping of 180-degree, it also comes to its initial position. That's why we are needed this else statement here. Means if we have to change our position again to the initial position, then we have to initiate this else factor here. Otherwise we could initially have only if and else statement, nothing here of the else here. But as we have to make our positions to the initial of the servo motor, we have to use else here. So basically I am summarizing whole of this function 1 again. Here we are assigning the servo positions for two servo motors. Here we are taking input from the MKR Wi-Fi board. Here we are setting variables for timers. Here we are setting up the servo connection, and in this loop we are checking the inputs from the Arduino MKR Wi-Fi board, and based on the input from the Arduino MKR Wi-Fi board, we are using servo control functions to flip the positions or change the positions of the servo motor, and both of these whole servo motors position changing process is included within this single flip function. Thank you. So now I will describe or explain the coding part of our primary microcontroller board, that is Arduino NCAR Wi-Fi. So through this board we have controlled our stepper motor, we have also controlled our two IR sensors and also the ultrasonic sensor and also the relay switch. So now let's see, for the stepper motor we have assigned their values of the pins to 3 and 4. For working of our LCD, we have included the two libraries called wire.h and liquid crystal I2C.h. Our display is a I2C model, so we have used this library. If any simple 16:2 display LCD display is used, then we have to use the liquid crystal.h display, which is pre-installed in the Arduino IDE. This liquid crystal I2C.h library is usually not pre-installed in the Arduino IDE. We have to separately install it and add as a zip form or zip file. And here we are initiating the LCD. Our LCD is 16:2, means it has 2 rows and 16 columns. For we have used 16,2. It also comes in another variant of 20:4. So for that we have to use here 20,4. For ultrasonic sensor, these are the very basic variables. For trigger pin and echo pin, these are the distance. And for limit switch, we have setting the pin and values. And for IR sensors, we also have set the pins to their respective values. And for timers, this is a very important thing. here the timer is also a input from the Arduino MCR Wi-Fi board, and also the here in the timer we have used timer for sanitization, means how much time will the objects be sanitized. For UV light there is a UV pin 1 for on and off of the UV light, and for servo we have used the servo pin 9, that is the basically input from MCR Wi-Fi board to the Arduino board. Now let's see how our another part works. We have here set up the motor pins, stepper motor pins. We have here enabled the pull down for limit switch. For that we have used the input pull down and pin mode function. We have set direction to the backward, that is digital write. This will open the tray, digital write, and we have bring the traverser to the position. Here we have set up our LCD. By LCD.begin we have initialized the LCD. LCD.clear has cleared its screen. There is no text will be in at the first. LCD.home will set the cursor to its initial first positions, and LCD.print is used to print any text on the LCD screen. We have here set up the ultrasonic sensor by using to output and input, also the IR sensor by input, and we have enabled the UV light by pin mode output. We have here disabled the flip as long as no object is placed, otherwise it will create a problem. In the void loop, we have used a loop to execute something, and for that we have execute our purpose. We have created a function called execute. In the execute there are some main controls or main functions like display control. This will show the text we wanted to show on LCD screen. Traverser control, this will change the position of the traverser for smooth opening and closing of the tray. And disinfectant, this is the physically function which will on the UV light and our disinfection process will start. Change time, this is a function to change the timer or the time for the sanitization process. And here the repetition of the same functions are doing. You can see the function of every or the work of every function. Beside it I have commented on it. Now let's see how the display control works. The display control is basically the set of predefined functions for the LCD, that is LCD.print to print anything, LCD.set cursor to set the cursor to its initial positions, and these are the repetitions, and we have operated this as case wise, in which case we wanted to print what. According to that we had set up the whole thing, and it's a very long code, but it's also at the same time it's a repetition. Now let's see how this disinfected process went. By initiating the digital write function, we are setting the value of the UV pin to high. That means by the help of relay switch the UV light will on. It will wait for a time, that is the this time divided by 2. Actually this is the time the user has set to the object to be sanitized, and after the half of the time is spent, the two servo motors will initiate the flip, and the servo motors will flip the plates by using this digital write servo pin high delay, and after the digital servo pin low. By this the two servo motors will flip the plates, and then the UV light will directly hit the opposite surface of the object, and again it will sanitize for half of the time, rest half of the time, and after that the UV light will close and our sanitization process will be complete. So there are the two functions, int sense 1 and int sense 2. These are for the two IR sensors to detect anything in their range like hand or any object, so that they can give their input to the MCR board and open tray event is being initiated. And specially I have here attached another function called insense 1 and 2, and I need to explain why I have included it. Many times when the user is placing its hands in front of the one IR sensor, as our setup is very small and two IR sensor is very close, another IR sensor also may take that as a input. To remove that confusion, to let that problem not happen, I have created this function called instance 1 comma 2, which will ensure that the user wants to place his hand in front of which IR sensor, that will only work and other IR sensor will not work, and it's very efficiently runs our machine. and I think it's a very good characteristic of the coding part. Now this is the traverser control to control the stepper motor using a 4980 driver, and according to that our tray will open or close. Now here is the change time function. As I have previously said, the user can change the default time of the sanitization by this change time function. And how we can change? By varying the distance of hand from ultrasonic sensor. For that, how we are controlling the ultrasonic sensor, let us see in the upcoming part. So this is the catch distance function, usually measured, or usually it measures the distance of hand from the ultrasonic sensor by some basic functions like digital write, delay microseconds, and after that it converts that distance by multiplying some multiplying factor to microseconds, and for that we have here introduced another function to convert the microseconds to distance in centimeter. And this is here I introduce the multiplying factor. By this multiplying factor it will convert the input from the ultrasonic sensor, and according to that it will take that input in the change time function, and by that the user can change the timer. So this was the whole coding part of the MCare Wi-Fi board. Thank you.